Hello everyone, welcome to my first video on university physics, and this is first year physics, and I'm starting with topic 1. It's linearization in physics. If you're new to this channel, please subscribe, share these videos with friends, help us grow the channel. It will give us more energy and impetus to develop and upload as many videos as we possibly can. Right now, let's look at the definition then of linearization in physics. We define linearization in physics as a process of transforming a nonlinear equation into a linear equation of the form y equals mx plus c, which describes a straight line. What is the aim of linearization in physics? The aim is to determine unknown constants through experimentation. That means some variables are measured, and then we of course end up with graphing. And from the graphs, we are able to determine the gradient of the straight line and the y-intercept there, c. Right, let's look at the first case then, first example in this video. My first example is this one here. We are supposed to linearize. So we are told in this case that z and t are measured, and a and b are constants that must be determined. And so we want to transform this equation so that it is in the form of y equals mx plus c. Through graphing, we'll be able to determine what the coefficient, the gradient is, and the y-intercept. And we hope that a and b would be part of the gradient or y-intercept. So how does the process go? Right, so we are told z and t are measured, which means one of these two should be subject to formula, or at least a function of one of these two, or maybe a combination of the two, right, should be made subject to formula, a combination in terms of product or quotient, as you will see in the coming examples. Let's look at the first one here now. Naturally, when you see t squared down there, you would want to multiply the whole thing by t squared and see what we would obtain from there. So I'm going to start straight from there. So I have number 1 here. We have z is equal to a all over t plus b all over t squared. So if I multiply throughout by t squared, I'm going to get zt squared is equal to, obviously, if you multiply this by t squared, you're going to get at plus multiply this by t squared, b over t squared times t squared, you're going to get b. Now, if you look at this form here, remember we are told z and t are measured. And in this case, z and t at least are together on the left-hand side there. And then we have t here. So clearly you can see that this is now in the form of y equals mx plus c. And so if you draw the graph of zt squared versus t, the gradient of that graph should be equal to the value of a. So basically we are saying a is equal to m, where m is equal to what? Gradient of the line. Gradient of the line. We do not know what these constant or variables are, and so we would not venture into trying to assume that the graph would be a straight line with positive gradient or negative gradient. Suffice to say that m should be equal to a there. So in other words, we are able to obtain a from the gradient of the graph of zt squared versus t. And so the y-intercept then would give us the value of b. So b would be the y-intercept, which is c. Now, let's just say for argument's sake that the graph line is a straight line of this sort. And therefore, we would say that at this point here, that's where the y-intercept would be. That would be the value of c over there. And so this is where your b would be, right? And then to determine, so basically we're saying here you would have t, and on the vertical axis, you would have a product of z and t squared as a one quantity. So gradient of this line here, and gradient, by now you have been students of physics, you understand that gradient would be change in y, that would be the vertical part, change in y over change in t in this case. So that will be delta, if I put zt squared in brackets, and this would be delta t. So your gradient m then would be delta zt squared all over delta t. This would be the value of m. And so we see from here that that would actually be the value of a, and the value of c would give us the value of b. So this is how you go about the first one here, linearization, basically transforming that equation into a linear function or a linear equation of the form y equals mx plus c. And so from m and c, we're able to determine the values of a and b, which are constants to be determined, of course, in this case, graphically. Right. Now, let's look at the second one. The second one in this case would be this one here. In this video, I probably will come again with another video on linearization, but the second one we have in this video is this one here. We're supposed to linearize this. What is the purpose? The purpose is to determine alpha and k, which are constants, but we are told p and v are measured. And so because p and v are measured, like explained in the first one, we have to make p or v subject of formula in this equation here, which obviously is not a linear equation, as you can see the exponent there, or make a product of the two or quotient of the two subject of formula, and hope that one of these would be on the right hand side. So you have y versus x, as it were. So with an exponent like that, the first thing I'm going to think about is introduction of the use of logs. We have to use logarithms here to deal with this one. So let me capture number 2. Number 2, we are basically saying pv to the power alpha is equal to k. So if I take natural log on both sides, natural log of pv to the power alpha, the answer should be equal to natural log of k. And looking at this part here, it invites me to think about the law of logs, which says basically, we get a separate page here. It says the natural log of the product m times n is equal to natural log of m plus natural log of n. One of the laws of logs. So looking at this part here, p and v to the power alpha, you would take p to be represented by m, and n to be equal to v to the power alpha. So therefore, on the left hand side, I have natural log of p plus natural log of v to the power alpha, and this is equal to natural log of k. Now, again, I'm going to have to apply the other law of logs here, because we have the exponent there. We want to get rid of that, or at least bring it down. There's another law of logs that says natural log of m to the power p is actually equal to p times natural log of m. So this form here is the form that I see there. Therefore, this is the form that must take me to the solution. So I'm going to say this implies that natural log of p plus alpha natural log of v, that should be equal to natural log of k. Now I can take this to the left, to the right hand side, and on the left I'm going to have natural log of p, and this will be equal to minus alpha natural log of v plus natural log of k. Now notice something here. Our m is to determine the values of here, determine the values of alpha and k. P and v are measured, so at least I have p on the left hand side, v is on the right hand side. This, ladies and gentlemen, is actually in the form of y equals mx plus c, where m is equal to negative alpha. So negative alpha equals m. That means alpha is actually equal to negative of our gradient, because our m is gradient. Right. Now, the value of k can be obtained from the y-intercept. So we're going to say, that's the first part. The second part, we're going to say the natural log of k is actually equal to c. But what is the natural log of, what's the definition of natural log? It's actually log to base e of k. In this case, equals c. And how I deal with this when I'm explaining this to my students is that the e takes the place of c, and the log is gone. What do you have on the left-hand side? You're going to have e to the power c. So you can obtain k by simply raising e to the power the y-intercept, which you would obtain from the graph of the natural log of p versus natural log of v. Remember, the y-intercept will be natural log of k. Again, assuming that all the values are constant here and that the value of p is greater than 1, in which case log of p, natural log of p would be positive, and same applies here and there. This graph and alpha, if alpha is positive, you would have a graph that looks like this. You would have natural log of p there on the vertical axis, and then you have down here natural log of v. So the graph would be slanting downwards because the gradient would be negative, assuming alpha is positive. And so the y-intercept there, whatever you find there, would be equal to the natural log of k. And that would be the y-intercept. And gradient of this graph here would be equal to minus alpha. And so alpha would be the negative of gradient. And obviously from here, if you remember in terms of functions, gradient would be negative here. You would have to draw a triangle like this. The moment you draw a triangle on the left hand side, you know that gradient will be negative. It's going to be that difference or gap divided by that. So this would be delta natural log of v into delta natural log of p. The answer, the solution would be negative there. Right, so that is how you deal with question number 2. Remember, ladies and gentlemen, we're dealing with linearization here. The aim of linearization, again, to remind you, is transforming the given nonlinear equation into a linear equation of the form y equals mx plus c, and the aim is to determine unknown constants through experimentation and obviously graphing. So that will be number 2. Let's move on to number 3. Number 3 is this one in this case. There is number 3. We are told that p is equal to a exponent that. So notice that exp represents e to the power. This represents e. So in this case, this will be written as e to the power that expression there. We are told p and q are measured. And the constants that need to be determined are a and b. So we have a here and b there. Now let's start by rewriting that expression or equation. Number 3, we have p equals a exponent minus b q p. This means p is equal to a e to the power minus b q p. That's what it means. Now, again, p and q are measured as it is stated here. P and q are measured. Remember, it means we have to make one of the two subject of formula, or at least a combination of the two, or even a function of each one of the two. So in this case, it is natural to introduce logs because of the exponent there. So we're going to say in this case, natural log of p is equal to natural log of a e to the power minus b qp, like that. Again, taking a and this expression here as m and n, and the product here, we have the product. The log of the product is the sum of logs of the two numbers that are multiplying. So this will be equal to natural log of a plus natural log of e to the power minus b q p. And on the left, we have natural log of p, like so. Now, if you look at this part here, the natural log of that, basically the answer would be just that one, because we have natural log of e. Remember, natural log is log base e. So log base e of e to the power that, it should be the power. Let me remind you again of laws of logs. One of the laws, very serious laws of logs here. I'm basically saying log base k, x of x to the power m. The answer is m. To see this would be to transform this into, if you would want to transform, let me just get another page here. So basically I'm saying here, if you are told that log base x of x to the power m, and I'm saying the answer is m, in order for you to see that this is true, let, for example, let log base x of x power m be equal to some number k. We want to prove that this expression equals m. So let equal to some number k. Change this into an exponential form. It will be x power m. Remember what I say? The x must come here. Leave this one there. The x must come here. The k will become a power. This will be called x power k. Same base. What can we say about the powers? Powers must be equal. So m equals k. But what is k? It's the entire of this expression here. So it means this actually is equal to m. So that makes sense. So therefore, this must simplify to, on the left we have natural log of p, on the right we have natural log of a minus b q p. Right. Now, notice we are told here that if you check here, we're told that p and q are measured. So I need to make sure that one of them is subject to formula or a combination. In this case, we already have p as a subject to formula. Now here we have a combination of p and q. There is p and q there, a combination. So I can actually rewrite this in this form here. I can say that this is going to be equal to natural log of p is equal to, check this how I'm going to write this one, minus b, and I'm going to put p and q in brackets, plus natural log of a. Why am I doing this? Because p and q are measured. So p and q are measured. So I can plot the graph of natural log of p versus p and q, product of p and q. Natural log of p versus the product of p and q. The graph line, the gradient will be equal to minus b, and of course the y-intercept will be natural log of a. Remember, our m is determining the unknown constants a and b. So this would be a form of y equals mx plus c. Again, m would be equal to minus b would be equal to m. So from here you can see that b will be equal to minus m. And also here from there you would say natural log of a is equal to c, and then as if you can remember, this is just equal to e to the power c. So we're able to determine the value of b and a by linearizing this expression here into that form. I must say something here, that I'm having natural log of p on the left hand side, but you can also have a product of p and q, because this now becomes like x, and that will be like y. So you can have this one there and this one there and still be able to obtain a straight line graph and obtain the gradient would be whatever the coefficient you have here. In this case, if you put this one here, the b would be actually reciprocated. Let me just show you what I'm trying to say. What I'm trying to say is, suppose you decide to say, no, I want this one on the left hand side to have that as subject, the product. So then you would have to take this one this side, bring this one that side. So you would have, I hope you can see what I'm writing here. You would have minus, so minus b, bringing it this side, it will be positive. So you'd have positive b qp is equal to, this would be minus natural log of p plus natural log of a, like this. Now, remember our aim is to have this as subject to formula. You would have to divide by b throughout. So this would be qp is equal to, and then what do you have here? You have minus 1 over b, natural log of p, plus 1 over b, natural log of a. Now, so this one is in another form. So you would say that this is equal to y equals mx plus c. Now, you would have to determine what m is from there. I mean, what b is from there. So you'd have minus 1 over b equals m. And therefore, from here, you can clearly see that actually b will be equal to minus 1 over m. Now, once you know what the value of b is, from there, you're going to say 1 over b, natural log of a is equal to c. C is obtained from the graph. So from here, you know what the value of b is. Multiply both sides here by b. Natural log of a is equal to bc. But what is b? This is the expression for b. So natural log of a would be equal to minus 1 over m times c. And so from here, you would say value of a would be e to the power minus c over m. So you can obtain, and you can obtain it either way, either this way or this way. And the answer for A and B should be the same. From here, whatever you get from here, from this approach, and whatever you get from this approach, answers should be exactly the same. Right. Let's look at number 4. Linearization, and example number 4 we are looking at. Here is example number 4. Now, from your high school physics, you would recall that this is actually from Doppler effect. Now, we are told that F and V are measured. So constants that need to be determined are F naught and V naught. So now I have to make sure that I have F and V separated, or at least on the same side, multiplying or dividing. And then I must have either F and V on the right hand side as well. So the first approach here is to remove this guy, F naught. Divide by F naught both sides. This takes me to page number 5, question number 4. It's F is equal to F naught, V naught all over V naught minus V. So what I'm saying is divide both sides by F naught. So it's going to be F over F naught is equal to V naught over V naught minus V. Now notice that we have an expression down here, which is a difference of two terms. So in this case, it's wiser to reciprocate both sides. Reciprocate both sides. What do you get when you do that? You're going to get F naught over F. Remember, this must go up and that must come down when you reciprocate the expression. Here you're going to have V naught minus V all over V naught. Use term-wise division here. Term-wise division. Term-wise division that I speak about in my maths videos. Using term-wise division here, you're going to have, on the left-hand side, you still have F naught over F. On the right-hand side, you're going to have V naught over V minus V over, so V naught over V naught minus V over V naught. So clearly you can see that this is F naught over F is equal to 1 minus V over V naught. Multiply by F throughout. So this is going to take you to F naught is equal to F, and then here you're going to have minus V over V naught times F. Now, notice something here. V and F are measured. Here it is. F and V are measured. So at least I have a product there. But I'm going to rewrite this because I want either F and V to be subject to formula. So I'm going to rewrite this as follows. I'm going to take this expression to the left-hand side. So I'm going to have now F naught plus V over V naught, F is equal to F. Now rewriting this with F as subject to formula, it gives us the following. Taking us to page 6, it should give us the following. It should give us, I hope you can see it there. Let me move. All right, now that's fine. So it should give us the following there. It should give us, remember I told you, have F on the left. It's going to give us F naught plus V over V naught F. Now we're not done yet. This takes us to F is equal to, watch what I'm going to write here. I'm going to write this as 1 over V naught, and then I'm going to say VF, and then I'm going to say plus F naught. Now this is perfect because now I'm going to have Y equals mx plus c. So I'm going to plot the graph of F versus the product of V and F, and therefore the gradient should be reciprocal of V naught, and the y-intercept should be F naught. So m will be equal to 1 over V naught. So clearly from here you can see that V naught equals just reciprocal of gradient. And obviously F naught is just going to be your y-intercept. Notice that M and C are obtained from the graph. Which graph are we talking about? The graph of F versus the product of V and F. Remember F and V are measured. So this would be measured quantities that you can plot on the x-axis, and that would be on y-axis. And then you are able to obtain the gradient from the coefficient. You are able to obtain one V naught from the gradient of the graph, and then y-intercept gives you the value of F naught. Right, I'm moving on to question number 5. I have 8 questions here that I want to go through. Hopefully I can manage to do this within or under 30 minutes. This is question number 5. We have J is equal to 80 squared exp. That expression, remember this is e to the power minus phi over kt. The question says k is a non-constant. So like 2 or maybe 5, whatever the number is. But we are worried about j and t, and we're told j and t are measured, and so we are required to determine a and phi as constants. So let's look at how we linearize this. Now, this is a tricky one because you see here we have a and t squared, and we're told here only t is measured of these two. One is a constant. So the best way to separate these two is to divide both sides by t squared as follows. So this would be number 5. J is equal to at squared exp exponent minus phi all over kt. This can be rewritten as j is equal to at squared e to the power minus phi over kt. Now divide by t squared both sides. You have j all over t squared is equal to a e to the power minus phi over kt. Now I'm going to take natural log on both sides because of the exponent there. Natural log of j over t squared, which are both measured according to this instruction here. We are told that j and t are measured. So I'm fine here on the left-hand side. On the right-hand side, I'm going to say natural log of a e to the power minus phi over kt. Again, applying the law of logs on the right-hand side, I'm going to have natural log of a plus natural log of e to the power minus phi over kt. If you remember in the example number 4 or number 3, I can't remember exactly. I think number 3. I explained that this one here is actually just going to be the exponent of e as a solution. So this is going to be natural log of a, and then here this is minus, so minus phi over kt. On the left hand side we have natural log of j over t squared. That's what we have. Now let's look at what we need to measure or determine. The constants we need to determine are a and phi. So a and phi, these are constants we need to determine. So now I can just rewrite this thing. This will be, I can rewrite it as natural log of j over t squared, and then this is going to be, watch this, k is a non-constant, we're told, minus phi over k times 1 over t plus natural log of a. And so this will be represented by y, or representing y, mx plus c, where m is equal to that. Remember, k is a non-constant. So what it means is now I have to plot the graph of the natural log of j over t squared versus the reciprocal of t, 1 over t. Once I plot the graph of this versus that, the gradient will be equal to minus phi over k. The y-intercept will be actually equal to c. So from here you can say that minus phi over k equals m, and you can see from there that how do we obtain minus phi? So minus phi, so let me just get phi. Phi will be equal to minus km. Remember, k is a non-constant, and m is obtained from the graph as gradient. And then from here you can actually see that capital A is just going to be e to the power c, as explained in example number 3. This is how you'd go through number 5 in terms of linearization. This was a bit tricky, but yeah, through practice you should be able to handle these questions. Let me go straight to example number 6. Like I said, I have 8 of them, and I have after this I will have 2 remaining, and I have to move very quickly here because time is really against me. Right, so now let's look at this one then. This one, it says linearize that. In other words, we're told delta y and t are measured. So the aim is to determine g is a constant to be determined. So we have only one constant to determine here. And if you look at this, it's already in the form of y equals mx plus c, where c equals 0 in this case. But let's just show you what we're trying to say here. 6, we have delta y is equal to half g t squared. if I draw the graph of y equals mx plus c, obviously there's no constant there. If I draw the graph of delta y versus the graph versus t squared, the graph of delta y versus the square of t, the gradient should be half, gradient should be half g. So this, for example, these functions, assuming that we're dealing with positive quantities here, you would have something like this. T squared there on the y-axis, delta y. And your graph would be a straight line through the origin like this. And gradient of this line would actually be equal to half g. So I would say half g equals m. And what is g equal to? Twice m. M is obtained from the gradient of this. Remember, this would be delta y, and then this would be delta t. So m would be equal to delta y over delta t. Whatever you obtain here would be the value of what? Of half g. And so from here you can solve for g, which is a constant we're interested in. Let me move quickly to example number 7. And again, if you would recall, this is actually what you did at some point in grade 12, where you were required through a formal assessment to determine gravitational acceleration. This is actually g for gravitational acceleration. You dropped objects from some different heights above the ground, and then you're able to obtain the value of g through linearization and graphing. Right, let's move on to number 7. Here is number 7. Again, from grade 12, if you remember, this is actually coming from Einstein's photoelectric effect. So we have HF is equal to HF naught plus EK. We are told EK and F are measured. What we're interested in is to determine H and F naught. If you may indulge me, H is actually Planck's constant and F naught is actually what we call threshold frequency. So we're supposed to determine these two from the graph that we obtain after linearizing this function here. So EK and F are measured, which means we have to make one of the two subject to the formula, or at least a function of the two. So let me go straight to example number 7. And number 7, I'm saying HF is equal to HF naught plus EK. Right. If I make EK subject to the formula, I'm going to say EK is equal to, watch this, this expression has to go to the left-hand side, but I already have HF there, minus HF naught. Now, notice something, that E and F are measured, which means I'm safe in this case. I can say that this is already in the form of y equals mx plus c. So what are we saying? We're saying if I draw the graph of EK versus F, the gradient will actually be equal to h. So m will be equal to h. After obtaining what my value of h from here, I can go straight and say what is my hf naught equals c. And so from here, f naught will be equal to c minus c over h. But what is h? M. So this would be actually minus c over m, and that would be the value of f naught. And remember, c and m are both obtained from the graph. Right, so we're taking m from there, value of h from there, bringing it here, because remember, our aim is to determine h and f naught as constants. So here you're able to determine h from there. Now that you know the value of h, you can come here and obtain the value of c, and then you're able to find the value of f naught. Of course, the value of c is obtained from the graph. So c is from the graph, h is from the gradient, and then f naught would be obtained by just dividing the two, of course, negating our solution there. Right, example number 7 sorted. Let's go to number 8, the last one in this video. There is number 8. Again, if you remember, this is actually from internal resistance. If you watching this video from South Africa, this is internal resistance, grade 12. We're told here that I and R are measured, and we're supposed to determine E and R. These are constants. Let's go straight into it then. So what is our solution here? Our solution is number 8. We are saying E is equal to I r plus r. Now, naturally, what one would want to expand this first. So if I say that E is equal to I r plus I r, then what two quantities that are measured, I and r? Okay, so I want to make sure that I have either capital R or I as subject of formula. Now, if I want to make capital R subject of formula, I'm going to take this expression on the left-hand side. So I have E minus IR equals IR. Rewriting this, IR is equal to E minus IR. Dividing by I throughout, remember I must make R subject of formula or I subject of formula. I'm going to have R is equal to, check this, E times 1 over I minus R, because I cancels here. And dividing this by I is the same as this expression. Now you can see that this is in the form of y equals mx plus c. Where is my m? There is my e. Where is my c? Minus r. So if I plot the graph of r versus the reciprocal of I, my gradient should be e, and my y-intercept should be the negative of r. So in this case, I'm basically saying the constants I'm supposed to measure, E, should be equal to my gradient, and minus R should be equal to my y-intercept, and so R should be equal to the negative of y-intercept. So this is the story of linearization. I most likely will come back again with maybe another set of questions on this topic, and then move to other topics in physics, the first year physics. All right, like I said, if you're new to this channel, please support us by subscribing and give us feedback, share these videos. We truly value your support. All right, God bless. See you next time.